Hello, everyone. I'm super excited for this webinar. Even though it's still fairly early in the morning for me, for you, Kevin, it's a little bit later, but still very happy to have you here. Kevin, do you want to introduce yourself quickly?
Yeah, sure. So thanks for the invite. I'm very happy to be here. My name is Kevin. On the internet, I usually use now Nivek as a name. I am a Google developer expert in Angular and web technologies and work as a freelance software engineer. I am basically, probably you hear it on the accent, I'm from Switzerland. Yeah, and besides that, I write a lot of blog posts together with my good friend Thomas Tryon. We are working on AngularExperts.io. So feel free to check that out. There we are releasing always new content, blog posts, videos, and so on. We also have a bunch of ebooks there that we published. And besides that, I stream quite a lot on Twitch. I also do a lot of YouTube videos and stream also on YouTube. And yeah, in my free time, I really like to watch animes, as you probably can see there in the background.
Now we're talking.
And favorite anime is One Piece, of course.
Reasonable.
And reasonable, right?
Reasonable.
And besides that, I'm also a big soccer fan, football fan for American soccer. And yeah, looking forward to tonight's Champions League game of Real Madrid. That's my club.
Yeah, that's nice.
So
that's
basically me.
Where's this Nivek thing coming from? Because I still remember you were online as Kreuzer code, so I was looking for Kreuzer code and I was like, where is this guy? So where's Nivek coming from?
So it's not as creative as you might think. Like I wanted to have an online name. So I was thinking about what would be a possible name. And Nivek basically is Kevin backwards, right?
Oh, Jesus. I did not.
It just sounds cool. So.
It does sound cool. I expected like a super fancy story, a little bit of
no.
shame for my friends from like primary school or something.
Nope, not a fancy story at all.
I could have made that connection, but I didn't.
It's cool that you didn't, because I thought it's so cheap to use my name just backwards. But if people don't see it, that's cool.
Maybe I'm also just stupid.
No.
All right.
I don't think so.
We'll see throughout this webinar. Okay, let's talk signals. But before we get to that, as every webinar that we're doing here from JetBrains, if you have any questions, feel free to put that in the chat. If it makes sense, I will interrupt Kevin throughout his presentation. Otherwise, we have dedicated slots throughout this webinar to ask questions. So if you have anything, just drop it in the chat. We might not get immediately to it, but we get to it eventually. And because this question comes up always, and even though I put this slide here, the question probably still comes up. This will be recorded. This will be available on YouTube. This is basically how the internet works. The internet does not forget, including this webinar. So if you have to have a break, dinner is ready, something like that, and you want to come to this later, feel free to just go to the JetBrains TV YouTube channel and check it out again. So having this organizational stuff out of the way, Kevin, do you want to take it from here with your presentation?
Yeah, I think that sounds good.
And we discussed this earlier, but I'm now a certified StreamYard expert, so I can put the slides up myself. Watch this magic.
Ooh, wow. Cool.
Impressive, right?
Yeah. So since this is a webinar, I thought like I will do most of live coding in my ID. And so I was thinking, how do I structure this content? Because there may be like some people who are new to Signals, and maybe we have some advanced users. So I try to basically start with the basics and then also go a bit deeper into the topic. So with Angular 17, we not only got an amazing new logo. By the way, Jan, how do you like the logo?
That's pretty fancy. I like the gradient a lot, even though I'm not able to reproduce it, but it's pretty cool.
I have the same issue, but it's pretty cool. So we not only got that, we also got amazing other features like control flow, defer loading, improved SSR story. But one of the important things that we also got is stable signals. So we already got signals in Angular 16 as dev preview, but now we also got them stable in 17. And I want to show you what this is. So before we start, I have to make a confession, because I don't know if this is embarrassing for me or not, but you can see we start with an empty component. It's a console demo component. We use one component in there, an ng-web console. And ng-web console is basically a visualization of our console log statements. So we can see whenever I do console log, we get hey there. And the reason for that is because I am on a Swiss keyboard with a German Swiss key layout, and I don't know how to bump the console font size. So I thought, let's go with a cheaper version, or let's take the easier way and provide a ng web console component, which is, by the way, available on NPM. So,
This is great.
yeah. Okay, but we are not here to speak about ng web console. So let's go ahead and create a value. And we can say that value, well, how about creating a signal? So we created a signal, but it's red. And the reason for that is that the signal always needs an initial value. So let's go ahead and give that some value. So we say value. Cool. So we successfully generated a signal. But what is that now? So the official answer is probably Angular's new reactive primitive, but I like to think of a signal as a box that holds a value. So let's go ahead and rename that to box, and we can give that box some values. So let's say we have a box and we put some shoes into the box. Now this box has a couple of special capabilities. One is that it can notify you when the value changes. And we will later see how that is important. So the box can give you a signal. The box has also some cool capabilities, like we can say we have something in the box, but of course we can take out the value out of the box. So if we would do that, we would get shoes. So nothing special so far. Interesting is that the IDE here is really helpful because it tells us the type. So the type is automatically inferred. And we can see that the type is writable signal. So what is the difference between signal and writable signal? Well, let's use, again, the help of the IDE. And we can see that a writable signal extends a signal. And a signal itself doesn't have much on it, right? But the writable signal extends that signal and adds a set method, a update method, and an as read-only method. So let's see how we can use those methods. So let's say we want to put something else into our box. So we can say this.box.set, and we put in a t-shirt, for example. Now, the important thing to notice here is that nothing happens. It's not this push-based like we are used from RxJS, where you pass in your callback and you get notified if the value changes. Here, again, we just put a new value into the box, and we have to take out that value later again if we want to use it. So pretty straightforward. Now, let's say in our box, we don't have a string, but we have a number. So, and we want to increment that number. What you, of course, can do is say we take the value out of that box and increment it by 1. So that would work, and we will get 0, 1 log to the console. But there's a much better way, and that's the update method. With update, we can say that we want to update the value, and we can pass in a callback. And in this callback, we can simply access the value. So that's the current signal value, which would be 0, and increment it. So those are those two functions, set and update. So writable signal allows us to push or to set or update the value. Now, if you have used Angular or signals, if you played around it in the dev preview, you may notice that you also had something like this, like mutate. And that was a function that was mainly used when you had something like a non-primitive, like an array in here. And what mutate would allow us to do something like this, v.push, so that would be access to the reference, and you could push 1. But the Angular team decided to remove that function, and for good reason, because this basically introduces the same problem that we have today if you have an array, and you just push it, and you pass the array as an input to an onPush component. Then ng-on changes would not run. So therefore, they encouraged you always to use update, which means here you would just spread v, clone the array, and push 1 in.
So that even means that in the update method, you still have to work immutable to get the benefits of a signal.
Yes.
Correct. Okay, cool.
So then we have seen that there is this as read-only method. And what is a possible scenario where you might want to use that? So let's say I have a injectable, and that injectable is provided in root. By the way, live coding got so much easier with GitHub Copilot. Look at this. So let's call it console demo service. And I have a counter here, which is a signal of 0. So now what I can do, I can say, well, I get a hold of this counter service. And that's wrong, AI. And we inject, sorry, I have to call it console demo service, right? And now what you can do is you can say console demo service.counter, and you can set 5. But maybe that counter is meant to be like a counter that is incremented, right? So you want to avoid that. So what you would do is probably you would do something like that. Call this internal counter. Then have a increment method, which is a public one, which would do this.internal counter update, and then a public counter, which is basically this.internal counter as read-only. And now, as you can see, we cannot set 5 here. So we would need to go over the increment method. But what we can do is we can call it. So we can take the value out, but we ensure with that you cannot update and set it. If you've already used RxJS, this might be familiar because you have subject. And what we were usually doing was something like subject.asObservable. That was a pattern that I've often used. That's the exact same thing here. Cool. So that's the basic API of Angular signals. So now let's go to some component and we will see how this is used inside Angular. So I created a counter component, and this counter component has a title count and a button increment. So let's go ahead and create a counter, which is a signal of 0. It's not a signal of 0, it's a signal with an initial value 0. And we display that in the template. Again, to take the value out, we just call it. And then we add a click handler with an increment function. And on that increment function, we simply do this counter and that. So AI is not yet so good with signals, to be honest, because this is plain wrong. So now we have a counter, and if we click, we can increment that counter, right? And that's cool. But let's quickly think about that. Like, why does this work? Because wouldn't it be fair to say that this is actually the same as doing console log and then isn't this the same? Because here we just update the counter, right? Maybe here I should go with a number. It would be fair to say that this is the same, right? Because we just do an update. Isn't this the same as clicking once? So the difference is that in Angular, or in our counter example, we are still in normal Angular environment. Means we click something, and then we have this library called zone.js, which monkey patches all the async APIs, and then tells Angular, well, an async event occurred. Go figure out what changed. And then Angular runs change detection through the component tree and recalls those template bindings. And therefore, it's essentially the same as saying console log this counter again. So recalling the counter, right? And that's basically done by zone.js. So that's just some important piece that may not be clear, like if you start using that. It's still working with zone.js at the moment. Now, let's take it to a bit more sophisticated example. So let's say instead of just displaying a counter, we want to display a double count. So let's go ahead and create a signal, double count. But instead of creating a normal signal, we create a computed signal. And the computed signal or computed is a function that is also provided by Angular, and it takes in a callback, which we call the computation function. And in this callback, we can say this.counter times 2. And now, whenever our counter changes, we can see how the double count also updates. We will see in a minute how this works behind the scenes, because this is pretty interesting. But before we do that, let's also say we want to log that, basically. So we would go ahead and we can create an effect, which is basically a side effect. And in the side effect, we can say count is, and we want to log not the count, but the double count. Count is this.double count. So now whenever you change, this effect gets called, right? So if you have worked with NGRX, this might seem familiar because you can set values, right? You can take out values, you can calculate derived values, and you can have effects which run side effects. So how does that work behind the scenes? And the reason why that works is because Angular behind the scenes uses a graph, so a reactive, no, just a graph. But this graph consists out of reactive nodes. And reactive node is kind of the base class. And there are multiple or two classes that extend this base class. And one is a producer and one is a consumer. And so far we have seen what writable signals are, we have seen what computed signals are, and we have seen what effects are. And a writable signal is always a producer. So a producer is something that produces reactivity, that produces new values, right? A computed signal, on the other hand, is a consumer because it consumes some values that are produced by a producer, so by a writable signal. But at the same time, it's also producing new values. So a computed is basically used to calculate derived values. So therefore, a computed signal is a producer and a consumer. Depends on if that value is again used. And an effect, on the other hand, is just a consumer because an effect doesn't produce new values. The only thing that you would get back from an effect is the effect ref, which is only useful if you want to manually clean that up.
Could you set the value of the base signal in the effect? And because I mean that's basically how NGRX effects work, right? You take an action and at the end you return a different action. That's not how signal effects work though, right?
Yeah, so when you want to set a value in an effect, you can do that, but you have to specify a custom flag, allow signal writes true. So there is an option at the end of the effect, which basically tells you, that would be here, where you can say allow signal writes. So by default, it will throw an error if you update a signal inside here, but you can say allow signal writes true, and then you could update signal.
But this should still be a different signal, otherwise you basically have an infinite loop.
Yes, definitely. Exactly. That's also why they prevent it from default.
It makes sense. It's a very reasonable default.
Yeah, I also think so.
Okay, cool.
Then, let's look at the code again. So let's say we have a counter, which is a normal signal, which has an initial value of 0. Then we have an is-even, which is a computed signal that basically calculates if our counter modulo 2 is basically even. And then we have an effect that just logs that. And later we do an update on our base signal. So let's see what is going on behind the scenes here. So I tried my best to research the Angular algorithm and visualize it, right? Because it's not such an easy thing to visualize, but I hope I came up with something that makes it more clear. So initially, this looks very complicated, right?
Nah,
it's okay. So I was speaking about the graph. Many things should be familiar if you see this. I mean, let's go through it. So we have a graph update that is initially happening, and we can see that we have our count signal, which is a writable signal. We have our is-even, which is a computed signal, and we have our effect. So those are the pieces that build the graph. Now, what is new that our count has a version and a value. So we start with value 0, and the version is just a counter that gets incremented whenever the value changes.
Can you zoom in a little bit? The graph figure's a little small.
Yeah, like that. Cool.
Yes, that's good for my bad eyes from sitting too close
Cool.
to the monitor.
Okay, and then the counter, for example, because it's a writable signal, so it's a producer. So each producer has a list of its consumers. Each consumer, on the other hand, has a list of its producers. And since our computed signal is a producer and the consumer, it has a list of the consumers and the producers, right? And interesting is that for each producer, you kind of store the current version and the value. So here we know this is our producer. So the count signal is our producer, and we store for it the version and the value. And the same for our effect. Our effect does the same. Now, there are a bunch of details that will probably go too deep, but they also distinguish between liveness of a consumer and if you are a live consumer, which in this case we are because you are a live consumer, if you are consumed in an effect or a template, then this arrow is there, otherwise it might not be there. But that's just some detail for completeness, but I don't think we should focus on that.
And the version is just used for dirty checking in the template then, which was rendered the last time, or?
The version is used later in the phases that we will see in a push phase and pull, but it's basically an optimization on how to make the algorithm more performant.
Gotcha. Okay.
So yeah, what is going to happen next is we have a counter.update. So that's this line where we update our base signal. And now what is going to happen is that here, this value version gets incremented. So it gets set to 2 because it doesn't produce the same value. So there's also an equality check. So if you would do counter set 0, nothing would happen, right? Because it's the same value. And you can also customize that function. So there is even a function that you can pass in. And let's say you would have a product array, a product object that you put in here. You could say we just checked on the ID and not the whole object, basically. So what is going to happen then, the version gets incremented and the new value gets set. And then you push dirtiness across that graph. So we call that the push phase. So you push dirtiness across across the graph to your consumers, basically, from this point of view, to your consumers. And that pushes it further down the graph. So that's the first phase. And that's important because here nothing else happened. No recomputations are run, nothing else. So just counter update, nothing else. And then we enter this pull algorithm. And that's basically the interesting thing. The effect itself reruns. So Angular schedules it behind the scenes and re-executes it. So the effect will just be run by Angular. We don't do that manually, right? And then the effect will basically start by polling down its consumers. So it will poll, and then our computed signal will further poll to our base signal. And what will now happen is it will check, okay, I have stored version 1 for you, but your version now is 2. So that means the value changed. So I'm going to pull the new value. And then it will pull the value 1 and update here the version it has stored and the value. Then it will recompute itself and update its own version. So it will then have version 2 and the value false because 1 is not an even number. And then it will further go down, and the same thing happens for the effect because the effect now knows, well, I have stored version 1 for you, but the version is actually 2. So I probably have to pull the new value. And that's what's basically happening. And then the effect recomputes or re-executes the callback. And this looks complicated, but I tried to kind of simplify it with that. So you start with the effect which polls, the is-even polls, and then if necessary, you do pull the new value, recompute, update your internal stuff, and so on. You can see the recursion that is going on here.
That's pretty cool.
I also think so. Yeah,
that's very much simplified compared to that like massive.
Yeah, definitely.
I like it. Do you mind if we put in an interlude for like quick couple questions that accumulated throughout?
No, it's good. It's good.
Cool. Okay. one question that you will probably like the most, and I always like to start with questions like that. What is the WebStorm theme that you're using?
Oh, that's a cool question. The WebStorm theme that I'm using is called Skull, and it's a theme that I created myself because I wanted something that is very light on the eyes, right? So, and I also kind of have some color blindness, and therefore I created Skull. Yeah, on those pictures where you have like multiple colors, right? These numbers, I barely see anything like. And yeah, and so I created Skull, which is basically the idea behind this comes from this northern lights, so everything is kind of like themed like that.
Oh, that's cool.
And also, if you want to know more why I like it, you can go over to Angular Experts, I think products, Skull, and there you can find it. It's currently a paid theme. It's I think $2 monthly and 20 yearly, probably, I think so. But yeah, I spent quite some effort to make this happen, to be honest.
Yeah, I bet. All right.
Yeah.
When you were talking about how the signal gets updated when you with the increment method, the question came up, well, wouldn't the same thing work with normal values due to the way that change detection works in Angular? Because you're still clicking on a button, the counter, if it's just a number value, would still update in the views. So how is that different, and what are the implications for change detection in that sense?
Yeah, so it would still work with the normal thing, right? With a normal number. But yeah, we will see the change detection implications in a bit.
Okay, then I will hold on to that question.
I think, yeah, we will go more into detail there, yeah.
We will come to that later. What is the added value compared to RxJS?
So one thing, again, we will see that soon, which is basically the change detection. Then also, I think it simplifies things for persons, but that's like, how to say, it simplifies from a user point of view. But if you see the concepts that are going on behind the scenes, because now we have push, pull, pull, basically. RxJS was pure push based. So there's also a debate to make if it's really simpler, but probably you don't have to dive that deep into the algorithm. But I think it's a bit simpler, and the main benefit will be, of course, local change detection, and we will see how it impacts the future. It will have a lot of benefits, but that's still, yeah, we will go deeper into that.
Yeah, one thing I particularly like about that, and saying that as an RxJS core team member, so it's very explicit when re-rendering is happening. While observables hide the producer are implications entirely for you, ideally. It's very transparent now when re-rendering is going to happen, basically when you call the set method or the update method. And that's something that I personally always liked about React with the set state method. It's very clear when a component will re-render, and you can use that information to batch certain operations and all those things. That was always very hard with Angular. Now this information becomes a lot more transparent, at least to me. So and if you haven't done that, but checking out the signal-based components, RFC, I'm super excited to see that come to life eventually.
Yeah, we will also show that later, the RFC for the future.
I didn't check out the RFC while it was like ongoing, but I think like a week or two ago, and was like, okay, I'm super excited for seeing that again. Cool. Covered that. Okay, let's hold on to the other questions and come to that later. So if you want to take it from here again.
Yeah, so one thing that I wanted to show you now that we've spoken about the graph, let's take again this example. And one thing that I want to show you here, let's say we have a counter 2, which is also a signal. And we add another button, which we call increment 2. Increment count 2, something like that. So of course, we have to go ahead and add this function, increment 2, this dot counter 2 dot update. So we basically have the same. And double count now is this dot counter, but we do plus this dot increment 2. And let's also, let's see, not increment 2, counter 2, of course. Let's also do some clean code, and let's call this total. So instead of double, we call it total, right? And let's display counter 2. Cool. So we have 2 counters. So we can increment the first one and the second one, and also our computed updates. But let's say for some reason we want to increment the second one, but only update once we increment the first one. So what we can do is we can go ahead and use a function that is called untracked. And we can pass in a callback where we use another signal inside. And then what is going to happen, we can still increment 2, but our double count, which should be total, but yeah, that's the total, doesn't increment unless we do it with the first, unless we increment the first counter, right? So with that, you can kind of say this is not tracked in that graph that we were showing previously. So based on the questions that we've seen, you were already too quick. But yeah, I was thinking that you might think at this point, like we speak about reactivity, but what about this guy? Because we already have reactivity in Angular. We already have all that stuff, right? So what is the main motivation of using signals? And that was one of the questions. And one of the main motivations is change detection. So let's go into this change detection demo. And also here, change detection demo component. It's one file. I put multiple components in there so that I don't have to hop like between the files. But what we have a grandchild component, which is used in a child1 component. Then we have a child2 component, and both are used inside the parent. So now Angular has this component tree. So that's this visualization of the tree. So we basically have the parent component, child1, grandchild, child2. And now let's say we log something. So what is going to happen here? So the first thing, again, our good old friend Zone.js kicks in because it monkey patches the async events. So he knows, well, a click happened. So he goes and he tells Angular run change detection because a click happened. But he doesn't deliver like a click happened in a grandchild. He just says, go run change detection, go figure out. And then Angular basically goes through and figures out. And now you can see whenever I update the color here means we ran change detection for that component. So we run change detection basically for the whole application, right? And here we have 4 components, which is not a lot. But imagine you have a bigger application which uses then even third-party libraries. You will have like bigger component trees with quite some components. So the Angular team is aware of that. And what we did in the past is we added a change detection strategy, which is called onPush. So let me quickly go through here and add onPush everywhere. And then we will see how that impacts our tree. So change detection onPush, and then also here. Cool. So now all the components are onPush. And now if you click something, you can see how child2 always stays the same. So we basically do not run change detection for child2 because we can skip entire subtrees because they are onPush. And in onPush, change detection only runs in 3 scenarios. If the input changes by reference, if the component was marked for check, or if basically a click occurred inside here. So cool. But now let's say, therefore I quickly have to, let's say I move that button down here inside our app component. So like that. And now I say I have a increment observable. So let's go with an observable, and we will do a increment observable function. And as you can see, I prepared a counter service. And let's say on that counter service, we have a counter stream, which is a new, let's go with a behavior subject. I think that's the most similar in terms of behavior from signals, because you also start with an initial value. And then what we can do is this .counter service .counter .next, and then we basically increment the value. And now let's consume that inside our grandchild component. So take away that, grandchild ops. And here we would do counter service counter. And you can see that we have to import the async pipe. And now that's a bit annoying. I mean, it's cool. We get better tree shakeability over the common module, but still we have to import it. And now what we have here is,
that fancy IDE that you use there, that would have suggested that to you. Just saying.
Okay. Okay. Good. Let's also I want to quickly change the log something button. So here the text basically should not be log something, but we call it increment observable. So now if I increment this observable, let's see again the change detection, right? So still the whole tree is checked. So can we do better? How about, does it help if we maybe, I don't know, let's see, maybe it helps if we put in a signal, right? So of course we have to import the signal, and then we add another function, increment signal, and we say this.counter service .counter. And now we've already learned that we can use this update function. So we do another increment signal, and then on the top we would use grandchild signal. And now the cool thing is we don't have to use any async pipe, we can just call it. And then we have grandchild signal. And if we do the observable, everything gets checked. And now let's see the signal. So in the signal, did I do something wrong? Because that should actually only check this one. Yeah, because I didn't call increment signal. So I call increment observable. But now we call the correct thing. We can see how.
I just didn't wanted to call that out, you know.
Okay. Yeah. Yeah, if I don't know live coding, it has to go wrong.
It is hard.
Yeah, but now we can see that with the observable, we run the change detection for the whole tree. But now if we do the signal, child 1 doesn't run change detection. So the parent still runs it because we still have like the event that occurs here. So the component gets marked for check, right? But we have to be a bit careful with that local change detection. It's a cool feature, but notice how initially I had the log something button here. I had to move it up to the parent because otherwise it would not work, because then we are still in the current times, we still have the click event coming from here and the component, and all the tree would get marked for check, and then it still runs for everything. So this can be very confusing if you just read like we have local change detection. So we have currently local change detection in certain cases, but this shows you how this might work in the future. And the Angular team can also extend it in the future in such a way that we can drop out of Zone.js and just run change detection for this. Also, I think in the future, they want to do it like pretty fine granular per view. So if you have like multiple ng-ifs, that would be multiple views. They can run it only per view, but currently it's still for the whole component. And that's one of the big benefits of signals over RxJS.
Massive benefit, like being able, like everyone has like if you're having like a page or something, those are usually pretty big, hefty components, and running entire change detection over that it's costly compared to like, okay, being able to just run change detection on like certain parts of that view. It's going to be a major difference in performance, particularly if you don't really have to change anything other than migrating to signals progressively. I'm very excited for that.
Yeah, me too. And even if we get then to a future where we have zoneless, because zone is still like you'll have to load it, which has its own weight. Sometimes it's magic, sometimes it runs too often. So I think this will be a huge improvement, right?
To be fair, it's always magic. I'm pretty sure there are like 5 or 6 people on the planet that know how it actually works. And probably 4 of those are from the Angular team, so...
Yeah, that's also true. That's true. Yeah. Okay, cool. But still, again, what about this guy, right? Because
I like this guy. It's a good guy.
I also like it. Yeah, because still, what is going to happen with RxJS? Because, okay, cool, we get better change detection, but what does it mean for RxJS? So will it go away or not? I don't think it goes away. The Angular team, I think, once mentioned on a podcast that they can see a future where it becomes optional for certain cases. But I think for most cases, it's still valid, and we will see what are those cases, or we will see one of those cases. And if we still say we need RxJS, we also need a way to convert signals to RxJS and vice versa. So how can we basically work with both of them? And to show you that, I again prepared, or we are going to use again my super ng web console. And we have a counter signal. And let's say we want to have a counter stream. By the way, I always use this dollar because I kind of like this convention. I don't know, Jan Nicholas, is this a good convention, or?
I use it too. I personally think an IDE should help you and like just tell you, and TypeScript in general, like, hey, this is an observable. In like JavaScript end, I totally would use it, but I would never write a project just with JavaScript these days. I use it myself. Do I think it's neat or useful? Not really. I don't know. It's more a habit.
I kind of like it. I kind of like it if I just have a service and then I do counter and I know everything with dollar is a stream. It's kind of
it's not. Yeah.
But that's personal taste. But we can say to observable. So we have two functions, to observable and to signal, and we can say this.counter. So we convert our counter stream into an observable. And now we can use the RxJS operator. So we can say we delay that by 1,000 seconds. We come down here and we subscribe to that. And then after 1,000 seconds, 1,000 milliseconds. So after 1,000 milliseconds, we get counter 0. Cool. So let's say now we want to convert it back. So let's say we have another counter, which is not a signal 0, but to signal. So we convert our stream to a signal, and then we would do console log another counter, and we log that out. So now we would immediately get another counter, and then later counter 0. That's the delayed value. But we never get basically another counter 0. So we will never get an update here. And even the initial value is undefined. So what can we do about that? So what you can say in the toSignal method, you can pass in a config object, but you can say require sync, for example. So you can say, well, I want a sync observable. But of course, our observable is not sync, right? So we will get an error in the console, which I don't know how to bump. So maybe I should extend the web console to also handle the errors. But so yeah, you get an error. But what you can say, we don't require sync, but we still start with an initial value of 5, for example. And then when we run that, we get immediately another counter 5. And then our counter delayed emits 0. But why don't we get that update? And again, it's the same thing because we don't call it. So we would need to go ahead and after that update, call it and say console log, update counter, another counter, something like that. And then we give it like 2,000 milliseconds. And now we would get another counter 5, counter 0, and updated counter 0. So that's kind of the idea. So we can convert from signals to observables and from observables to signals. So now you may ask, like, where does this make sense? And I tried to come up with an example, which is a GitHub user search. And therefore, I prepared here a GitHub user search component. Let me go a bit smaller. And we have an input field. And let's say we want to basically fetch a bunch of users from GitHub. Now what we would need to
really
do,
quick, how long do you think you need for this demo for the GitHub search? Because we have a couple of questions again, and I want to make sure we cover those too.
About 10 minutes, I would 5-10 minutes. 10.
Okay, then let's do questions first, so that we not forget about them, and then
good.
come to that.
That's good.
Cool. one thing that just came up that is really interesting is, why do you use require sync if you're using an initial value anyway? Is the require sync a mandatory property that you have to specify, or was this just while coding it happened?
It's not a required property, but it's just basically for you, I see it more as a tool that you can use to ensure that you have an initial value on this observable. So you can say, I want this to be a sync emission. But you don't use require sync together with initial value, right? The initial value you would use if you have required sync false, which is the default. So you can, if you want to have an initial value, which is often important when you use it in a template, then you either use initial value to make sure that you have an initial value or require sync.
Oh, okay, that makes sense. This, we need to circle back a little bit. This came up earlier when you had the graphs open. Why would we need a non-live consumer node if we compare with live consumer?
Non-live consumers is basically to avoid memory leaks. So basically, if you would have a, by the way, Ilya, shout out, he's often on my stream, cool guy. So basically, you would use non-live consumers if, to avoid memory leaks. So if you have a computed signal that is using a signal in its computation function, and then suddenly you would go ahead and say computed signal equals null.
Yeah.
Then that can be garbage collected. And if you would have that connection, basically, so if you still have that arrow between the signal and the computed signal, you cannot garbage collect it. So that's the idea for non-live consumers. But if you use it in an effect or template, you cannot anyway not just set it to null.
Are there any additional consideration or patterns that you use maybe for unit testing signal-based components? And signal-based components might not be like the 100% technical right term, but components that use signal, I think is the intent here.
Yeah. So I have, to be honest, I've never written unit tests so far for signals because I haven't used them so much in practice yet. Yeah. But I don't see like big impacts. Maybe I use sometimes marble testing, but for async stuff, and that's something you cannot use here. But
I mean, in the end, you would anyway. The way you usually write unit tests is, okay, you perform a function or something and check that a value is updated in a view. And you should be able to do that just out of the box with signals. So there, I personally, I'm in the same boat as you are. This is just from like experience what I would expect, but I don't see any changes really coming in that sense.
Yeah.
Cool. And the last question that we had, probably not the last question because there are more. If you have multiple signals that are listening or that in an effect, how do you know which triggered the callback function in the effect?
Basically, it again works with that graph, right? So you would make an update on a writable signal, or basically somebody produces a new signal, and that pushes dirtiness then. And then when the poll happens, he only polls for the one that was dirty and not for the ones that were not dirty, right?
Right, but that's like framework level. You as an application developer, you would just get like all the latest values and deal with that this way, right?
Exactly.
Okay. That makes sense. Let me quickly check if there are more questions now in the meantime. Okay, I think... Oh, that is a great question. Is there a state manager based on signals?
State manager, you mean like
NGRX.
like NGRX. So I know that NGRX has now a toSignal method, which allows you to basically select signals from the store. But and I think they also have a signal-based component store or something that I've seen, but I've never used it.
Yeah, we had Marco on the Angular Plus show, and he was talking about signal store. It's not Redux-based, so very interesting, more functional than NGRX is. And it can be used for components and global state. So pretty cool pattern. I know that RxAngular is working on a signal-based state solution, if they've not already pushed it out. And I would be Ankita or Ankita, Elf, and those state managers are not setting on signals in the long run because it's just more performant for anything state related. I think this is another great one, and then we get to your demo. Are you using IdeaVim?
Yes.
Are you? Jesus.
Yes.
Okay, you're like a hell lot smarter than I am.
I told you we were chatting before we went live. We were chatting about the Moonlander,
Yeah.
And I initially switched to the Moonlander, and then you first have the columnar layout, then you have the Moonlander config, and I have Vim even on top. So my brain was kind of exploding the first days because it was too much. Even now the presentation I'm doing on like a normal Mac keyboard, because if I speak and I have Vim and all the config coming together, I was like, on stream I usually use the Moonlander, but then today I was just like, let's go with the safe version.
All right, I have to try IdeaVim at some point. I feel like
IdeaVim is super cool. Like I would recommend it for basically everybody. Vim Motions is like the best.
It's super strong. It's just another thing to learn, right? Okay.
Yeah.
Let's go back to your presentation. Can we get it in like 6 minutes? Can you do that?
Okay. Let's do this. Okay, good. So we have this GitHub user search input, and we have a bunch of use cases because when you type something quick, right, you don't want to fire like 10 requests. You only want to fire a couple of requests, like basically one at the end. Then also, you probably don't want to fire on each keystroke. And another thing is you don't want to fire on every keystroke. So only if you didn't type for a certain amount of type. If I come with Kreuzer, then I want to fire one request. If I do Kreuzer and go back, I don't want to fire because it's still the same, right? And if I do A, I want to fire a request for A, but I have no control over the timing of the request. Maybe this takes long. And if I fire one for B, and this one, or A comes back faster, or no, B comes back faster and A takes longer, then I would I want to avoid the situation that I display the wrong data, right? So there are a lot of use cases going on here. And I imagine, I don't know how to implement that without RxJS. But with RxJS, I have a certain idea how I can do that. So how can we use RxJS here together with signals? So let's say we have an input and we have a handle input function. And in this handle input, we would do handle input. And then inside here, we basically create a input change or input, which is just the signal. We start with an empty input because initially it's empty. And then we say we have $e or event. Let's type it as any. And we say this dot input dot set event target value. Probably here we should pass in the $event. Sounds like a good idea. And now let's go ahead and create some GitHub users. So, okay, we have this input, but how do we now implement all the features that I was talking about? And what we can do is we can say to observable. And now, basically, we go and we have access to the observable stuff. So I think of this as walking down the street. So on the left, you have the signal store. On the right, you have the observable store. And now you think, okay, well, now I need something more powerful. So let's go to the observable store. Then you walk through the store and you say, well, I want to use a filter. That sounds cool. Well, how about a distinct until changed, right? Then how about a debounce time of 500 milliseconds? How about I want to show some spinner? That's cool. Like show spinner, which can be a signal false. Then we can use, that's cool. Because I'm using the EIP for the first time now. I've never seen this. Wow, that's pretty nice. Cool. Also with the logo.
I was just saying that was first contribution to the WebStorm code base. I'm probably the only one for a while, but yep, new logo.
Nice, you did a great job.
Right?
Cool.
Senior developer now.
And certified.
And certified StreamYard expert, yeah.
Yeah, your career is skyrocketing.
Yeah, like the last 4 weeks. Play the LinkedIn game.
So yeah. So we want to show that spinner, right? Then we want to switch map because probably want to have some users. I think it's called search users. So again, AI is doing a great job here. And then once we load, we want to hide the spinner. So now we want to display those things in the template. But again, we are walking down the street and we think like, well, on the left side, we have the signals. On the right side, we have RxJS. Well, here we need to use the async pipe. So let's go to the signal store, because there we can call it. And we also can take advantage of some sweet local change detection, right? So then let's say, okay, we go to the signal store. And now we can say, and I imagine here again, wow, thank you, Jan. That's amazing. This is not amazing.
To be fair, all the work goes to Piotr, who did like everything else other than the logo. So
okay.
I feel like we have to give credits where credits are due.
Okay, good. Okay, good. So basically now I just display the GitHub user, right? And I use 4. And now if I start this and I type, I see the loading spinner, and I have a nice,
Look at that.
Nice GitHub user search. Like, it's pretty cool.
Yeah.
I don't know I don't know what your GitHub username is.
Me neither.
Me neither. Yeah, good. But you can see, imagine you have to write this without RxJS, right? So good luck, I would say, because this is cool. Now, before we wrap it up, this is basically everything that you can do today. So that's everything that is available, that is there, that is stable, right? So you can use that. But we were talking about signal-based components and the future and how it impacts those things. And let's take a look. And again, here, the idea is pretty cool, because now basically everything that is red is not there yet. So in the future, we talk about signal-based components. So we will probably get a signals true flag. That's not yet there, but it's also not final that we get signals true, but that would be then a signal-based component. I guess that has impact on change detection. So if you have like a click handler there, that it doesn't automatically mark the whole subtree, but it will only basically run local change detection then. Then there are a bunch of impacts, or this has quite some impact, because what would change is with signal true, this is basically a add input that we know from currently we would write this. Now the syntax changes. It's just an input, but this is automatically a signal. But you can still use everything that you use today, like alias required and so on. Then we would get model inputs. Model inputs is pretty cool, because imagine you have a signal-based component, which is just a toggle. So you can say this is a model, which basically allows you to also update that signal. And then you can use the banana in the box syntax here to update the signal on top, right? Then signal outputs, of course, again, different syntax, but it would be signal outputs. View child would be different. So view children, we would write in a different way, the view child as well. And it also has impact on the life cycles. So currently we have a lot of life cycles. We have on changes on init to check all the after content in it, which most of them I rarely use. I mainly use after view init, on changes, right, and on destroy. But in the future, we will have much less. Like, we will have effect, which is basically, since all the inputs are signals, we can use effects instead of on changes. And then we can use also for after content init, content checked, and the view checked, we can use signals. Then we will have a after next render and after render. Those are the ones that are already available, and we will still have engine init and engine destroy. But that's the big impact that signals have on the future of Angular. And I think that's also then, yeah, basically the whole framework will be built more around signals. So that's the idea here.
Yeah, I'm very excited for that. And then we just need to get rid of the add component decorator, and I'll be super happy.
Mm-hmm. Why is that something that is not...
I'm not a big fan of decorators in general. I would prefer a component function that does the same thing.
Oh, functional components. I think Brandon is also a bit a big fan
I like
of
this approach on that. I know he got a lot of hate for that, but I really liked it.
I don't know if he got hate for that, but I just saw that he's a fan of it.
Yeah. again, thank you very much for joining us for this webinar. This was great. I learned a lot about signals that I wasn't aware of before. So thank you very much. Really appreciate you coming on and
Yeah, thanks for
teaching us all
having
the
me.
fancy things.
Mhm.
If you don't
Sure.
mind, I will kick out your slides and do my StreamYard magic.
Sure, for free.
Haha. Look at that. So if you have any questions afterwards, feel free to reach out to me or Kevin. Here again, Kevin's information. I also not just have to play the StreamYard and LinkedIn game, I also have to play the YouTube game. So if you want to be notified about content like this in the future, we try to have this something like this somewhat regular. So check out the JetBrains TV channel and subscribe, like, blah, 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 blah. Again, Kevin, thank you so much. This was great. Really appreciate you taking the time.
Sure. And if people are interested in this kind of format, also feel free to follow the live streams. It's basically pretty similar.
Yeah. All right. Thank you very much, everyone, for joining us, and see you next time.
Thank you.